Hi, I'm John, and this is my video about the Microsoft well-architected framework. Today I'm going to be talking about the well-architected framework for Azure. And this is a framework that provides you the tools and the guidance to design and implement well-architected applications suitable for running on Microsoft Azure. We're going to be talking about what the WAF is and the supporting elements, and then we're going to be going into the 5 pillars of the well-architected framework. So what is WAF? Well, as mentioned, it's a framework for designing and implementing well-architected applications on Azure. This helps support us in the shift from the on-premises mindset into the cloud-friendly mindset and the kind of changes we should see in the application architecture. Ultimately, the goal is to produce high-quality, stable, and efficient cloud architectures. And there's 6 supporting elements, as you can see in the top right corner, of design principles, Azure well-architected review, Azure advisor, documentation, partner support and service offers, and reference architectures. So these are the tools that support us in architecting our application to meet the well-architected framework. The first pillar of the 5 pillars of the WAF are reliability. This ensures that our application meets the commitments we make to our customers. It has a focus on availability and recovering from failures, whether it's data loss, major downtime, or ransomware incidents. Examples are mitigating failure in one part of a distributed system. This is making sure that one part of the system and a failure in that part does not cascade to other parts of the application. We've then got PaaS replication across zones and regions. Microsoft Azure PaaS services often have built-in capabilities that allow us to provide regional redundancy or redundancies between data centers within a specific region. So these are some of the things that we consider as part of our architecture for the application. We then have IaaS and availability sets and availability zones. So zones again is about spreading the architecture of our application across multiple data centers within the same region. Availability sets allow us to ensure that, for example, 2 machines that make up the application tier of our application are not on the same rack in the Azure data center or are not going to be patched by Microsoft at the same time. So availability sets allow us to define how our compute resources should be spread out. We then have security. So a modern attack surfaces include system configurations, operational practices, and the social habits of system users. As part of the well-architected framework, there's a few areas to consider as part of security design. Things like identity and access management, threat protection, cloud security, information protection, information governance, insider risk management, compliance management, and discover and respond. So this area is really focused on the security of our application as one of the key pillars of the well-architected framework. We then have cost optimization. The cost of running services and running our application in the cloud is very different to what we're used to in an on-premises environment. In on-premises, we're typically used to big capital expenditures, and in the cloud, as we architect in our application, we need to think differently about how we manage budgets. For example, in on-premises environments, we may over-provision the compute power so that we can meet peaks. This isn't necessarily required in the cloud because we can scale up automatically, and this can optimize costs. So we need to consider all of these things to make sure that our business goals are justified against the budget that we're spending on the application. This also includes creating cost-effective workloads, avoiding capital-intensive solutions, and reducing unnecessary expenses and improve operational efficiencies. There's a lot of features in Azure of varying costs that we can enable as part of our application. We need to make sure that what we're switching on is justified, required, and it's given us value for money in the architecture of the application. Next, we've got operational excellence. This is around the ongoing operation of the application, ensuring that we've got the processes in place to keep the application running. We should, where possible, automate as much as possible around the deployment of new application code. We need to reduce human intervention where possible, and there's a lot of Azure services that can enable us to do this, and operational excellence allows us to consider these services. The final pillar is performance efficiency. This includes scaling to meet demands. So as mentioned earlier around on-premises and how we might over-provision our on-premises infrastructure to meet demands, we don't need to do this in the cloud. We can have, especially when using PaaS offerings, we can have our application scale up and down as required. The options related to PaaS vary depending on the PaaS service we're using. So we may use Azure App Service, for example, or Azure Kubernetes Service. So there's different options depending on the service, and that's what we need to consider as part of performance efficiency. Thank you for watching.